This is a presentation of a paper I wrote about importance-driven focus plus context for inspiration analysis in citation graphs. So I made this application to go along with it. So you can select an author and you can view all the authors that he is inspired by and the authors that is inspired by him. And you can view both at the same time, which lets you see these reciprocal inspirational relationships also, the purple ones. You can adjust the context opacity. You can also adjust the reach of the focus. And you can rearrange the layout dynamically so that it is easier to see the parent-child relationships within the focus. And there's some other functionality as well. So in the context of author-to-author citation graphs, how can we visualize inspiration? So how inspired is one source author by the other authors, and how inspired are they by him? So what is inspiration? My definition is if one author cites another author at least 8 times, he is inspired by him. So here S is directly inspired by A and C. He is not inspired by B because he only cites him 3 times. This leads to indirect inspirational relationships because S is directly inspired by A, but A is directly inspired by E. So S is indirectly inspired by E through A and also C. Also, the citation count matters, and we should take this into account when rendering the visualization. There are 2 subtrees of the focus graph. It's the authors that the source is inspired by, the red ones here. There's also the authors that is inspired by the source. This will lead to some authors being part of both trees, and so you have to render them in a way that communicates this. So here, S is inspired directly by M, and M is inspired directly by S. So they have a equidistant reciprocal inspirational relationship. Here also, S is directly inspired by M, but N is only indirectly inspired by S. This is a non-equidistant reciprocal inspirational relationship. So why is inspiration visualization useful? So we can use it to evaluate individual authors' inspirational contribution to a community, of course, but we can also use it to look at the inspiration dynamics within a group. And also, we can look at the structure of the inspiration graphs themselves and the substructures within it. So to do this, based on some selected author, we first must build a graph of incoming and outgoing inspiration, these 2 trees. And then for each author, we calculate a degree of inspiration. Then we can use this to drive some rendering characteristics. So the degree of inspiration calculation. It's based on a degree of interest trees by card, but it takes into account the number of citations as well. So I'm not gonna go into details about this equation, but basically what happens is as you traverse away from the source, the degree of inspiration gets less and less. And then you can use this degree of inspiration to drive some rendering characteristics. So what you do is you make a transfer function that takes as argument the inspiration type and this degree of inspiration, and then you return some render characteristics from it. For instance, it can return a material consisting of some color and opacity. So here, for instance, C, his inspiration type is that S is inspired by him. So he is red. And then you use the degree of inspiration. He has 0.83. You use that to say how much red color he gets, right? For instance, you can do that. So for all the nodes that can't be reached and therefore is not part of the focus, you can assign a context material. So here L, I, and K cannot be reached, so they are assigned the same context material. But also, you can, if a node gets a negative degree of inspiration value, you can assign it a context material as well. And this will let you adjust the reach of the focus by adjusting the K values. So this gives you focus and context with separate rendering settings. So you can change the opacity on the context only, for instance. It also lets you color the focus by the type and degree of inspiration within it. And of course, it lets you adjust the reach of the focus by adjusting these K values. So to make it easier to read the focus and the parent-child relations within it, you can rearrange it. And this should be done dynamically. It should be animated. One way to do this is by using a force simulation on the nodes. So what I was using was the D3 Force 3D API, which lets you simulate forces on the nodes. And this API comes with some default forces that you can use. A centering force that attracts all the nodes towards some defined center. A link length force, which tries to make all the edges the same length, a length that you can choose yourself. And a collision force that makes sure that nodes don't overlap. And what it also lets you do is customize your own forces. So what I did, I made a custom force, a radial layout force that basically places the source in the center, and then all the other nodes it will place such that their radial length towards the center equals their path distance from the source node times the link length. And also I made this straightening force that for every node it looks at its parent node and its angle to the center and tries to get the same angle, which will make the trees straighter. But it also will bundle them together like this. So to fix this, you can also adjust the collision force minimum distance, and this will separate the nodes away from each other. So let's look at some use cases. So first of all, you can do individual author analysis or evaluation of their inspirational contribution to community. So here we can see Jeffrey here is very inspirational in his community, but he's not equally inspired by it. Almost opposite to him, Yin Kai Wu is very inspired by the community, and he also has a lot of direct reciprocal inspiration relationships, but he does not have the same amount of people inspired by him. Another use case, of course, is group dynamics analysis. So, for instance, here, Pascucci is directly inspired by Hege, but Hege is only indirectly inspired by him back. Hege is directly inspired by Hagen, but Hagen is only indirectly inspired by Hege back. Hagen is directly inspired by Pascucci, but Pascucci is only indirectly inspired by Hagen back. So you get this circle of non-equidistant reciprocal inspiration relationships, which I thought was pretty interesting. And then finally, the use case that I think is most interesting myself is the analysis of the structure of the inspiration graphs themselves. So this is based on a paper by Young called Lattices in Citation Networks, where he identifies some common substructures in citation graphs. So he was looking specifically at paper-to-paper citations. So the diamond shape where one paper cites two other papers, and they both in turn cites the same paper. And he identified this as the most important shape because it shows both co-citations and bibliographic coupling in the most simple shape possible. And if you look at the inspiration graph of Thomas Ertl, you find a lot of these diamond shapes, which is not common for inspiration graphs. So I thought it was very interesting that he has a very big number of these diamond shapes. Looking at Valerio Pascucci's structure, you can find this crystal shape or this crystal structure, which itself consists of many of these substructures identified by Young. And there's, of course, some other structures that you can see. So importance-driven focus plus context for inspiration analysis can be used for individual author analysis, group dynamics analysis, and also graph structure analysis. And there's some other use cases. It's not only author-to-author citation sets. You can use it with group-to-group citation sets and journal-to-journal citation sets, and so on. But this, of course, means you need to adjust the minimum citation threshold and also make some adjustments to the degree of inspiration equation to fit that specific set type.